If you've ever studied electronics, you definitely know the feeling. Your desk is just covered in these tiny components, a total tangle of wires, and that sinking feeling when one little loose connection brings the whole project to a grinding halt. But what if you could build, test, and even break really complex circuits without ever touching a single physical wire? Well, that's exactly where we're headed today as we explore that huge shift from tangible breadboards to powerful browsers, all through the lens of a simulation tool called Multisim.
So, here's what we've got on tap. We'll start by tracing the journey from old-school breadboards to these new virtual labs. Then, we're going to peek inside the Multisim workbench and actually build our very first circuit. After that, we'll see the magic of simulation in action, we'll compare the virtual and physical worlds, and finally, we'll wrap up by looking at what all of this means for the future of engineering.
All right, so to really get why a tool like Multisim is such a game changer, we have to look back at the world it came from. How did we get from a cluttered physical board to a clean browser tab?
For decades, this was it. Learning electronics meant getting your hands on a breadboard. It was a very hands-on and, let's be honest, often a painfully slow process. You're arranging components, you're cutting wires, and you're just trying to debug this physical thing you've made. And one wrong component or one misplaced wire, that didn't just mean a failed circuit, it could mean a literally fried part, and you were back to square one.
The contrast is, well, it's night and day, really. The old way was just a minefield of potential costs, long delays, and yep, those fried components. Virtual labs like Multisim were born to solve exactly these problems. They give you this amazing environment where you can build a circuit in seconds and just experiment without fear, all without a single piece of pricey equipment in sight.
So we get the why. Now let's dig into the what. What does this virtual lab actually look like when you step inside? Let's go ahead and take a look at the workbench.
So at its very heart, Multisim is basically a digital sandbox for electronics. It's a professional-grade tool from a huge name in the industry, National Instruments. And maybe the best part, it runs entirely in your browser. There's nothing to install, you just sign up, and you can start building right away.
And the interface is incredibly easy to get around. On one side, you've got your component toolbox. Think of it as a huge digital library of every part you could need. In the middle, you have the circuit window, which is basically your main canvas. You also have a full instrument toolbar with virtual versions of all the tools you'd find in a real lab. And finally, the simulation controls, which are as simple as hitting play.
All right, enough talk, enough theory. Let's actually put this virtual workbench to the test. We're going to build one of the most fundamental circuits out there, a super simple circuit to light up an LED.
And it only takes 4 simple steps. First, you grab your components, no more fumbling with tiny little bins. Second, you place them and wire them up with just a few clicks, no cutting or stripping wires. Third, you can just double-click to set the values instantly. And fourth, and this is the crucial final step, you add a ground connection, which gives the simulation a 0-volt reference point to measure everything against.
Now, that last step, grounding, is way more important than you might think. In fact, forgetting to add a ground connection is the single biggest source of frustration for beginners. It accounts for up to 70% of initial simulation errors. It's that classic mistake that just derails the learning process. But in here, it's a fix that takes what? 2 clicks?
Okay, so our circuit is built, and most importantly, it's grounded. Now it's time for the moment of truth. Does it actually work? This is the payoff.
So you place the components, you've wired everything up just like the diagram said. In a physical lab, this is the part where you'd kind of hold your breath and flip a switch. In the virtual world, the question is exactly the same, but the answer is instant.
And this is the magic moment. You hit run, and the simulation is instantaneous. There's no ambiguity, no guessing games. It either works or it doesn't. And for us, that little virtual LED starts to glow, giving us that immediate visual confirmation that our design is solid.
But it's not just about seeing if it works, it's about understanding how it works. With these virtual probes, we can measure any point in the circuit in real time. So right here, we can see that exactly 500 microamps of current are flowing. Now that is a level of instant, precise feedback that's just incredibly difficult to get in a basic physical lab. This power to simulate and measure everything instantly is just incredible. But it also begs a really important question. In this perfect virtual world, what are we missing from the real one?
So here's the core of the debate. It's really all about trade-offs.
A virtual lab is absolutely unbeatable when it comes to speed, safety, and cost. But a physical lab teaches you things a simulation never, ever can, like the feel of the components, the hands-on skill of troubleshooting, and how to deal with the inherent messiness of the real world.
See, a simulation operates in this world of ideal conditions. It doesn't know about that one resistor that's just slightly out of spec or how heat might affect performance. For example, in the real world, if you add a second LED, it might just cause both of them to glow dimly. A simulation which is running on perfect math might just show one LED not working at all. It misses that subtle, messy, real-world result.
So, given all these differences, where does this leave us? Let's take a look at how this is really shaping the future of engineering.
Well, the answer to that great debate isn't about choosing a winner. It's about recognizing that the future is a hybrid model. The consensus from both industry and education is crystal clear. It's not either or. It's about intelligently combining the strengths of both of these worlds.
And this hybrid model is really the path forward. Students can use tools like Multisim to explore theories and test dozens of different designs safely in the virtual world. Then, they take that refined knowledge to the physical lab to build practical skills. It becomes the perfect bridge between abstract theory and real-world application. And this leaves us with one final, pretty provocative thought. We've seen how these tools are changing how we build things. But as these simulations become even more powerful and more integrated into everything we do, the bigger question is this: how will they reshape the very skills, the mindset, and ultimately the definition of what it even means to be an engineer?